In 4.3b, we're going to solve a system of inequalities. And it's very similar to the prior section where you graph an inequality, but all you do is you graph all the inequalities they give you on one piece of graph paper, and you see where they all overlap, and that will actually be your answer. So let's get started here. I'm going to first graph this first inequality of a line. It's already in y equals mx plus b form. Remember, m is in front of the x, and it's 2. That's slope, which is rise over run. So the run here must be a 1, and the y-intercept is 1. So let's plot the y-intercept of 1. From there, I'm going to move up 2 to the right 1. Before I draw the line, I have to look at the inequality to see if it's a solid or dotted line. Remember, if there is no equals to, there's no line. It's dotted. I like to remember it because this guy right here has the line, therefore I draw the line. So let's dot this one. And then I want to figure out what side to shade on. So I am going to pick, again, if 0, 0 is not on the line, I can choose it. So it's right there. I'm going to put 0, 0 in for the y and the x. So that would give me 0 is less than 2 times 0 plus 1, which simplifies to 0 is less than 1. Is 0 less than 1? Yes, it is. I chose the correct side, so I'm going to shade over here. Okay, this next one here is already in y equals mx plus b format again. I'm going to write down that m is the negative 1. That's what that is. And I'm going to do it as a fraction, so just put it over 1. The b is negative 3. So I'm going to go to the y-intercept of negative 3. From that point, I'm going to move rise of negative 1, so down 1, run 1, or right 1. This here is a solid line this time. And the nice thing is I can still use the ordered pair 0, 0 to test for this one because it's not on the line. So I'm going to put 0, 0 in here to see what I get. So here and here. So I'd say 0 is less than or equal to negative 0 minus 3. So is 0 is less than or equal to negative 3. Now that is not a true statement. 0 is not less than or equal to negative 3. It's greater than, which tells me this side is the wrong side to shade for the blue. So for the blue one, I shade on this side. But as they do that, I stop when I hit the red line because that's my new boundary. Now, I've graphed the system, so where are the answers? Everything in this region here is the answer. So I could pick any ordered pair. For example, I could choose this one right here, which is 0, negative 5, and I could go and put it back into this x and y and this x and y, and it should be a true statement for both. Therefore, it's a solution to the entire system. Okay, let's look at another system. This time I have 3 inequalities, so I'm just going to do 3 on the graph paper, and where all 3 overlap is my answer. This is a good review. These first 2, if you notice, are just equations or inequalities with just one variable. So these 2 are either horizontal or vertical lines. So let's just try to remember. To graph x is greater than negative 2, I'm going to go to the x-axis and find negative 2, which is right here. Now, the easiest way is to remember, you don't put it with the actual axis that you're on, you do opposite of it. So this is going to be a vertical line. It is just greater than, so it's a dotted line. Now I do have to shade. I can either pick the ordered pair 0, 0 and try it out, or let me show you this trick. If you read this statement here, it says the x's are greater than negative 2. On which side of the red line are the x's greater than negative 2? Are they greater than negative 2 here at negative 3 and negative 4? Or are the x's greater than negative 2 at 0, 1, 2, 3? Hopefully you realize it's on this side. So either put the ordered pair in, or you can logically think through this, folks. It will work. And it means this is the correct side. So I'm going to shade on that side. Okay, the next one. Let's do y is less than or equal to 3. So I have to go to y at 3, which is right here. Again, the y-axis goes up and down, so this one actually goes left and right. It's a horizontal line. The inequality would say it's solid. Let me show you my trick on this one. Again, I could choose the ordered pair 0, 0 and see if it works. But just read it. This says y is less than or equal to 3. Where are the y's less than 3? At 4, 5, and 6, or at 2, 1, and 0? Well, it's down below. So I'm going to shade this region just where they're both overlapping. So far, this is my new answer, is this blue and red region both. Okay, to wrap it up, we're going to graph this last one. This is an inequality with both variables. So when you have that, you're going to want to get it in y equals mx plus b format. And it's not, so to get y by itself, we have to move the 2, and we have to move the negative 3x. Go furthest out and work your way toward the y. So to move a negative 3x, I'm going to add 3x to both sides. So then I have 2y is greater than, I'm going to do the 3x, and then this is a positive 6, so it's plus 6. That's my inequality there. Wrap it up. It's 2 times y. To get rid of times, I divide by 2 and do that to everything. So I'm left with y is greater than 3x over 2 plus 3. Now let's identify the slope and y-intercept. Slope is with the x, it's 3 over 2. Y-intercept is the constant or the number by itself, which is 3. So to graph this, go to the y-intercept of 3, which is right here. From that point, I'm going to move up 3. Looks like I need a little bit more graph paper. So I'm going to go up 3, 1, 2, 3, over to the right 2, which will leave me about right here. This inequality symbol is a dotted line. And for shading on this one, I am going to choose to pick the point 0, 0. So I'm either going to be shading in this little triangular region or this region that looks like a quadrilateral down here. So if we just put 0, 0 back into this particular equation, we'd have 0 is greater than 3/2 times 0 plus 3. Simplifies to 0 is greater than 3. 0 is not greater than 3, so I have to shade upward from the black line. But then I'm being bound by these other two. So this right here is the shaded region. That is the answer. Any ordered pair in that triangular region will work in all 3 of these inequalities to make them true statements. If you want another one for practice, let's do this last one. I'm going to actually start with this bottom one here and graph x is less than or equal to negative 1. So x is negative 1 is here, is a solid line, and it's vertical. I want the x's less than negative 1, means I'm shading this direction. I'm now going to go to the top one because it's already in y equals mx plus b form. The slope is 2. Y-intercept here is negative 3. I'm going to go to negative 3 as the y-intercept. From there, I'm going to rise 2, run 1. This is a dotted line. And I'm going to test the ordered pair 0, 0 because it's not being used. If I put 0, 0 in here, I'll get 0 is less than 2 times 0 minus 3, which would say 0 is less than negative 3. Now 0 is not less than negative 3, so we know we have to shade the lower half of this right one. So I'm actually going to go back to this blue line and do a little bit more shading. Okay, so on the right one I have to shade downward. Now I don't want to shade over here in the blank spot because the blue line's not there. The only place the blue line they both intersect is right there, up to that point. Okay, let's wrap it up with this last guy here. I need to get y by itself, so I'm going to subtract the x. Then divide by 3. So y is less than or equal to negative x over 3 minus 3. Now to read this, there's really just a 1 sitting there in front of the x. So identify the slope, negative 1 over 3. The y-intercept is negative 3. So from negative 3, I'm going to move down 1 to the right 3. And then so now I'm going to get a solid line, connect the dots, check the shading on this one. I need to graph the region. I'm going to try 0, 0 and see if that one works in here. And I'm going to write it right up in here. So 0, 0 would be a 0 less than or equal to minus 3. So this is 0 is less than or equal to negative 3. 0 is not less than that, so I have to shade to this side of it. And I only go where there's going to be continuous overlap. So if I shade downward on the black, I don't start getting a common region until right here. So this right here is going to be the answer to our inequality system.